Okay, so let's have a look at how to create a new Clojure project. So I'm just going to create a new directory. Let's call it intro. Go in there. And the first thing we need to do is create a file. Called deps.edn, and this is an empty file at the moment, and it's basically can contain dependencies to other libraries whose functionality you might be using. In this introductory video we won't have any dependencies, so yeah, that's all we need. Then we can call up the editor and continue there. Okay, so I've started with Visual Studio Code. What you need to do also, you need to have this Calva extension installed in your IDE. So I very much recommend you use that. And you can see it gets 5 stars here from the rating, so you definitely need that if you want to use Clojure. Okay, so we need to open the folder. I'm going to just go straight here. You can also navigate there via the open folder menu here, but I already opened it previously, so I'll just shortcut that. And we don't need any of that. Let's get rid of all this warnings and stuff. In your case, you may not actually have these things here, these .calva. They will be generated automatically, and because I opened the project previously, it already did that. Another error we can ignore. So just click on the deps.edn to edit the file, and the minimal thing this file needs to contain is a pair of curly braces like this. So we can just save this. And okay, next thing we need to do is create a directory for our source files. I will call it src, and in there I will create a file called core.clj. Any Clojure file needs to have the suffix clj. And okay, we're in the editor for that file now. And you may know that Clojure is derived, or is a, let's not say derived, but it's belongs to the Lisp family of languages. And in Lisp and in Clojure, any expression you type needs to be in a pair of brackets. And in Clojure, every file must also start with a namespace. So I will do that here. ns is the namespace function, and basically it expects the namespace you want to use. So I will call it core, which corresponds to the file name, and I will explain more about namespaces a bit later. So just take this as a given for the moment. And now let's type, we want to do a whole hello world, so we're just going to print. And the way to do that, well, the first thing actually after opening bracket like this is we need to put a function. Now you can see here namespace is actually also a function, and to print something we use the function println, and then we follow that by a string like this, and that's the hello world. Now we want to try this out, obviously, and what we can do, we can start up a so-called REPL, which is the read, evaluate, print loop that Clojure provides. And this is kind of like an interactive environment where you can try out and test things. And the way to do that here with Calva is string alt C, string alt J, and we have to type the kind of project. So we're using this deps.edn format, so let's select that. And what actually happens is it actually starts up a server that you can connect to. So you can see here something's happening on the console here, something server started on port 49269. And here on the right it opens up a window showing the output of the REPL. There are some instructions here by default in green, and this is interactive, so I can actually type something here. You can see the cursor is blinking, and it will evaluate whatever I type and show me the result of that evaluation. So if I just type 1, well, evaluating 1 returns the value 1, so that's what I get here. And the other thing is you can see here this prompt. CLJ is always shown to tell you it's Clojure, but this thing here is the namespace I'm in currently, and by default when I start the REPL I'm in the namespace user. And what I want to do now is show you that I can actually execute these commands here in the editor. Basically I'm sending those commands to the REPL to be evaluated there. So let's go to the top line, which sets the namespace to core, and type Control Enter. And you can see that the namespace has changed to core. It was user before, so it actually executed this, and it's also showing this nil. So the nil actually means that the result of evaluating this statement here is nil. So changing the namespace to core is kind of a side effect, and the expression when you evaluate it actually returns a nil value. You'll see some other cases in a minute, but let's just evaluate this other statement here, this print line. I'll do that again, Control Enter. And here you can see we're getting the output. In other words, the println hello world is being printed to the console, so we can actually see the output here. And again, the print statement itself returns a nil as a result of being evaluated. And you can also see these nils are being blended in here into the editor. And as soon as I start typing here, make some modifications, those will disappear again. So I just typed enter twice and it removed those. So those are just blended in by Calva to sort of provide some feedback. So let's try something else. Let's try adding two numbers. Again, we start with the brackets, and because I need a function now, you can imagine that plus might be a function. And I can provide some arguments to plus, like 1 and 2. And we can evaluate that again. Control Enter. And here you can see that this actually, when I evaluate this, it actually returns a result other than nil. So you can see the 3 here and also the 3 down here. Now you may say, okay, this is a bit strange to put the plus before you put the numbers. Normally it would be something like 1 plus 2. Yes, that's a bit strange, but it has its advantages that I can type more than just 2 parameters to plus. So if I want to add all of these together, let's see what happens. We get 10. So it also has some advantages, and you get used to it after a while. It's logical actually, because you would implement plus as a function in Clojure, so it makes sense to put it at the beginning. Now what I also want to show you is Let's evaluate that again. Here we go, 10. I can actually hover over this and copy this result. And as soon as I start editing, it will disappear. But I can preserve this just with a comment and by pasting the value I had before. So as you can see here, semicolon is actually indicating that what follows is just a comment and shouldn't be evaluated. And that's one kind of comment. Excuse me. Sometimes you see this as well. Usually when the whole line is a comment. Maybe sometimes you have separators like this. There's also the comment block. I'll explain that in a minute. And another thing I can do to comment something is I can use this hash underscore. And that will actually comment just the following expression. So if I have something else, for another expression following this, like, let's put 1 plus 2 in here again. It doesn't actually comment the whole line, it just comments this first expression here. So that's quite useful in some circumstances as well. Now another thing you can do is, rather than evaluating one line at a time like this, you can actually evaluate the whole file directly by typing Control-Alt-C and then Enter. You can see here the comment, basically Calva put in a comment here evaluating file core.clj, and I'm being shown this 10 here, which is the result of this evaluation. Now maybe sometimes I want some code that I can use to test things, but I don't want to have it evaluated in the end, like when the whole file is being executed. And that's what this commenting is for. So I can comment is a function as well, and it will ignore anything that follows. So for example, if I just want to try something out, but it's not actually part of my program that I want to keep, which I want to have executed by some user, I can put it down here. And if I run this file now, you'll see it just returns null because nothing's actually happening here. This file just contains a whole load of comments. And but on the other hand, I can still actually evaluate this thing as a line by typing Control-Enter, just like when it was up here. So I can use this to try out things without actually influencing what will be run when the whole file is evaluated. And you'll see a bit later that this comes in quite useful. Maybe just a bit difficult to understand why this is useful right now, but anyways, just remember that you can write comments like this as well. So you can see already what's really neat about Clojure is this interactive way of working. As you develop your program, your functions, you can try out stuff basically line by line. You don't have to, have a complete working program and then try that, then test that. And I mean, if you compare this to something like Java, where you have to write a class and that has to be able to compile, and once that's compiled, then you can run that on the virtual machine to see if it does what you want. That's a lot more complex than what we're doing here, where we can just type a line and immediately evaluate it and try see if it works. So I think it's a big advantage of Clojure that you can test the stuff as you go. That's it for today, and next time we probably look at what sort of data structures Clojure provides. So I hope you enjoyed it, and see you next time.